In this tutorial, I'm going to show how to set up a simple circuit in Mason and run and plot it. Mason can be used with the TinyCAD schematic capture tool that I've modified with a special toolbar that allows you to directly access some of the Mason functionality. The first thing I'm going to do is selecting one library at a time. I'm going to click on the Mason library and put down a flag block. The flag block controls a lot of different output formatting, some of the simulation things that you can do in Mason, some of these controls. You can turn them on and off by double-clicking the show command, but I'm not going to talk about these in this tutorial. I'm going to put down a frequency block. The frequency block gives you the start and stop frequency and the step frequency for the simulation. I'm also going to put down some ports. These are where the energy comes into and out of the simulation. And one of these ports I'm going to give a 50 ohm impedance and 100 ohm impedance. So the reflection for the S parameter is going to be based on 100 ohms for this port. We're going to add a dynamic component next. The dynamic component is one that's algebraically defined, so the values can be anything, as opposed to a touchstone model. Touchstone models are usually measured data, and they're fixed in value. Control R is what I'm using to flip that around. So I'm going to place that, use my line tool to make the connection. I'm going to run Mason now. It's going to throw an error. And the reason it's going to throw an error is that I haven't uniquely defined the reference designators, and Mason needs that. Now if you miss, what that output is, the C button that's up here, that pulls up the console. This is what Mason outputs while it's running. And a lot of times it'll tell you what the error is and give you some suggestions on how you can fix that. So here it's telling me that I want to click on Special, Generate Symbol Reference. I want to make sure that I have all sheets checked just in case. And that will fill in port 1, T1, port 2, so I have unique reference designators. I'm going to modify this now to become a quarter wave transformer, the geometric mean for the impedance, and I'm going to make it a 90-degree line, and by default the center frequency is in hertz, but I'm going to go ahead and use a unit, so 1 gigahertz. And now when I run Mason and look up at my console, I'll see that I ran the single solver and it's done without any errors. So the next thing I'm going to do, by the way, if you hold down on the right click, you can drag this around and move the plot. So the next thing I'm going to do is hit P to plot this. And by default it pulls up a Smith chart. So let me zoom in a little bit because it's just spinning around there. So I'm going to plot from 0.9 to 1.1 gigahertz. And that doesn't really do anything for here. Now, if I plot the S22, what I'm really plotting here is not the impedance in the Smith chart, but the reflection. And because I don't have any reflection off of this port, 1 gigahertz, it's going to show up in the center of the Smith chart. But it's not really 50 ohms, it's 100 ohms. The touchstone file that Mason outputs doesn't really know anything about that. But what you can do is, in the plotting tool, you can actually define what the port impedance is. Now when I refresh, it will actually plot the impedances correctly for the quarter wave transformer. I can also go and plot lines of constant Q, and I'm not going to describe what the lines of constant Q are here, but it does plot that. It's useful if you're trying to do some matching work. And I can go to a rectangular plot, let me go ahead and change my bounds. All right, so now I have a much cleaner plot. I can see that my S11 is nulled at 1 gigahertz, which is what you would expect. I can see that the impedance bounces around. Worst case is around 10 dB. I can also go to plot unwrapped degrees, and that's going to give me the argument of S11 as it rolls around. Now, really, up here, I can type in pretty much any formulation that I want. I have a math parser. So when I hit the rectangular button, it plots, 20 log abs S11. There's no particular reason why I couldn't put arg of S21 on here. However, when I do arg S21 in the normal rectangular plot, it doesn't unwrap the phase. If you really want to unwrap the phase, you have to use this, which is really just a rectangular plot with the unwrapping turned on. You can put in multiple plots here. And what we can also do is, since S11 and S21 are not really elegant, I can put single quotes and add in a little text that will give me something that looks a little prettier. So when I copy this, I can paste it into a document, PowerPoint slide, whatever, and it gives me this nice little plot.